Okay, since I already explained the problem in the email, I'm just going to go ahead and jump right into it. So we know that this box is hanging onto this this wedge by a 27.3 degree angle. So first of all, I'm just going to draw out my forces. I know that there's a normal force going perpendicular to the surface. Now, the second thing I know is that there is a gravitational force pulling down on the surface, going vertically in this direction, and that's the mg angle or mg force that I drew right here. Now I know that there's a frictional force pulling this way, so I write that right there. Now I'm going to go ahead and just label my x-axis going straight across and my y going straight down. Now go ahead and I'm going to look at the normal force right here, and I'm going to go ahead and label the x-axis and the y-axis, and I'm going to do the same thing for this frictional force, the x and the y. Alright, now let's worry about the angles. We know this is 27.3 degree angle just by using basic geometry. This angle extending is going to be the same as this one right here. So now we know that this is 27.3, so this has to be 62.7, and then vice versa for 27.3 and 62.7. Okay, now let's go ahead and start the problem. We know that because nothing's moving, the f net of x is going to equal 0, and the f net of y is going to equal 0. Now let's look at the x's. We know that nx minus fx is going to give us 0 because it's not moving. So let's go ahead and focus on the x's. We see that the n times the cosine is going to give us this right here. So n times the cosine of 62.7 minus, let's look at the f, f times the cosine of 27.3 will give us this, and then make that equal to 0. Okay, now let's look at the y's. We know that ny plus fy minus this gravitational pull is going to equal 0. Okay, so we go and we see that the n times the sine of 62.7 plus f times the sine of 27.3 minus mg will equal 0. Now we know that we are solving for the coefficient of friction, which is ms right here, mu s. Alright, so we're going to go ahead, and since we have two equations with two coefficients in it, that's not going to help us very much. So we're going to go ahead and just solve this x equation for n. So we're going to say n, just rewrite the problem, n cosine is 62.7. Now move this whole negative sign onto the other side of the equation. So we get n cosine of 62.7 degrees equals f times the cosine of 27.3. Now to solve for n, you're just going to divide this. You're just going to take this cosine and put it under this cosine of 27.3, and you end up with n equals f times the cosine of 27.3 over the cosine of 62.7. Now this is really good because we see in this equation right here we have an n, which is this n we just solved for, and also we have this f, which is in the actual problem here, which is going to help us. So we know that Fs, which is the static friction, is less than or equal to ms times n, the coefficient of friction times the normal force. And we know that right when it starts moving, it's going to be equal. So let's go ahead and just start plugging things in. We know that Fs equals the coefficient of static friction, and then just plug in this whole thing for this n right here. So times f cosine 27.3 over cosine of 62.7. Alright, now all we're going to do is take this whole thing and put it under this fs and divide, which is going to equal the coefficient of friction. So we just go ahead and what I'd like to do is just multiply by the reciprocal, so I can see that these two are going to cancel out right here, and we just end up with cosine of 62.7 over cosine of 27.3 equals the coefficient of friction. After you divide those, you end up with the coefficient of friction equals 0.52. Now this is how you find the coefficient of friction in this problem.